morning. So let us continue actually the lesson. Trigonometric functions we started with. So we learned a little bit about periodic functions, and I told you that this is an essential skill that you were supposed to be able to read the period of a function from its graph. That is a skill that there are good exercises in the book, probably you can practice. It's a little bit unfortunate in this book they have started talking about trigonometric functions before talking about the radians. Okay, and if I want to teach you radians now, then the exercises are all in degrees, then it would be a source of confusion for you. So let me just exactly follow the order in the book. Okay, So we talked about a periodic function. A periodic function was a function that actually repeats itself after an interval. That interval, the smallest interval with that property that you can take the graph of the function, copy and paste that part over and over again. It generates the graph. This would be the period of that function. The length of that graph would be the period of that function. Today we want to, in principle, we want to talk, I don't know why the book has talked about only sine cosine functions with these properties, but my point, I want to put it in a more general context. So if you have the graph of this function available, any function, not just sine, cosine or tangent functions, any function, okay, we want to see what happens to the graph of this function if I multiply the function by a number k. Okay, so let me call this function g of x. If I give you the graph of this function and I ask you to multiply that function, let us restrict things because in the book they are only discussing about the positive ones. I will tell you what will happen if k is negative. So I have a positive k, I multiply my function, yes, by k. This becomes a new function, so it will probably generate a new graph. I want to see how the graph of this new function is connected to the graph of the old function, if there is any connection. Yes, this is one question. Another question is that I want to do the same thing but with x. In principle, I multiply a k to x and then calculate f of kx, and then I call it a function h of x. So one possibility is to multiply your function by k. One possibility is not to multiply the function, but the argument, the input of your function by k. And then you generate a new function. I will give you examples. And you generate a function, you want to understand how the graph of h of x looks like if you know the graph of f of x. And then we have to answer two more questions, which would be the topic of the next lesson. What happens if I add a number to my function? Okay, so let me call it, I don't know, s of x. So this is also a new function. I want to see what happens in this case. And finally, let me call it t of x. What happens if I add this one? So we want to understand the effect of 4 operations on a function regarding the graph of the function. I multiply my function by a number, I multiply the input my function by a number, I add a number to my function, c can be any number, positive or negative, and the last one is that I add c, a constant number, to the input of the function. To understand the differences, let me start with a simple case. Y, for example, so let me tell you f of x. For example, assume that f of x is famous graph x squared. So everyone knows the graph of this more or less. Yes, it's a parabola, tangent to the x-axis passing something like this, yes? This is the graph of y equals to x squared, more or less. Okay. Now, for example, let me take k to be 2, for example. Then my question is that what is the graph of g of x, which is 2 times f of x? Yes? So in other words, I want to ask, if I draw 2 times f of x is 2x squared. So you see, I want to understand the connection between the graph of this function and the graph of my old function. I want to see if there is a connection between them. So this example is for multiplying my function by a number. Okay, let me give you example for h of x. H of x is f of 2x. Yes, so it becomes 2x. But what is f of 2x? It means that I need to go to my function, replace every x that I see with 2x. Yes, so this becomes 2x to the power of 2. So it becomes 4x squared. So my question is that, what is the graph of this function? Or, for example, let me choose c equal to 1. Then s of x becomes f of x, which is x squared, plus 1. I want to see if I give you this graph, can you immediately understand the graph of this one? And finally, what is f of x plus c? T of x is f of x. I have taken c to be 1, for example. This means x plus 1 to the power of 2. Why? Because f of x is an operator. You give the input x to it, it squares the input and gives it back to you. Now you have chosen x plus 1 as the input. The function will do the same thing. It will square it and give it back to you. So is that understandable? First of all, what are the differences? What is the difference between multiplying a function by k, multiplying the x by k, adding a number to f, adding a number to x? So if you want, this is one example. So we want to understand what is going on. Okay, so let us try to understand what is going on. For example, let us consider here. It is hard. I want to use GeoGebra, but before going to GeoGebra, let me just try to motivate you here. So, for example, let us see what happens. If I ask you to draw the graph of f of x, for example, you might set up a table, x and f of x, and let me draw another line for g of x, because I want to compare. So, for example, if you put x equal to 0 in the function f, it becomes 0 to the 2, and then you get the answer 0. Yes? And for example, let me just, 3 points is enough. Okay, let me just take x to be 1, for example. And if I feed it into the function f, I will get 1. Agree? And then if I put minus 1, what do I get? 1 again. And if I probably find these 3 points, because you know the final graph, it is enough for us. So this is 1. This is 1. This point is 1 and 1. That one. And this point minus 1 and 1 is here. Yes? And then if I connect these 3 points, so this is my parabola. This, if I want to write something on top of that, this is the graph of this function. Okay, now let us see what happens for g. This is understanding is good, because this is just a special case of function. So if I want to do the same thing with g, what will happen? If I choose 0 and put it in this function, 2 times f of x, what is happening? X's are not affected here. Agree? What is affected are the outputs. Then the output become double size of the previous outputs, yes? Because I am supposed to multiply f of x by 2. Okay? Here, f of x was 1. Now it is being multiplied by 2, it becomes 2. F of x here is 0. I multiplied by 2, it becomes 0. F of x is 1. I multiplied by 2, it becomes 2. What I want you to see is this blue line is some new information. Yes? You see, I am not touching x's at all in this operation. In this operation, I am multiplying my function by a number. I am trying to motivate you what will happen. Do you agree the values will be multiplied by 2, not the x's? The outputs will be multiplied by 2. Yes? And then if I ask you to draw the picture, this is important. This 0 and 0 will still be the same. But in the previous case, when I had minus 1, I was at the height 1. But this time I will be at the height 2. So it means that this line will be double in size. And it will go here. Yes, this is important to understand. And if I go to 1, previously I was at the height 1, but now I will at the height 2. So this means that this will also double in size. And then what happens? I will have this graph. So be careful. The precise shape is not important. I want you to understand nothing strange will happen. Every point on the graph will go 2 times higher. If it is negative, what happens, do you think? It goes 2 times lower. Yes? Because, for example, I don't know, if I have this function, y equals to x to the power of 3. Let us concentrate. I just want to clean it. This is why I write a little bit messy. So here x, I have -1, 0, and 1. For this function, what happens? -1, it becomes -1 to power 3, which is -1. And if I put 0, it becomes 0. If I put 1, it becomes 1. Let me multiply this function by 2, for example. Then the output -2 will be, -1 will be -2. This would be 0 again. This would be 2. The graph of this function, if you use GeoGebra to draw it, or it is easy. 0 and 0 is here. -1 and -1 is here. And then 1 and 1 is here. So, and then if you see GeoGebra, the graph would be something like this. Of course, why the graph bends like that, that would be the topic of Math 4 and derivative. But for the time being, trust me that this, of course, this should be tangent. Okay, now let me multiply it by 2, then I produce these numbers. Let us find them, okay? It was at height 0 here. I multiply it by 2, it remains at the point 0. But this was at height 1, I am multiplying it by 2, so the answer becomes here. So this will go up there. But now this is -1. If I multiply it by 2, it becomes -2, so it will go here, yes? And hopefully you see that every point that I have here, it would be double in size. This point here would be double in size, you see? And if you connect them, you probably understand that this would be the graph if I multiply it by 2 times. So it doesn't change radically. I don't know. So this will be the graph. So everything will be double in size. The height would be double in size on the same line. Yes. If you have this length on this line to be 1, now on the same vertical line you have 2. Yes. If you have on this line 3, then you will have it 6. Yes. So that is the effect of multiplying a function by 2. Yes. So here in this case, it seems that it becomes a little bit narrow or sharper. Yes. But for sine and cosine, the effect is much easier to understand. So for example, for sine and cosine, what will happen, do you think? So if I give you the graph of the sine function in one period, do you remember we had this before? So this is the graph of one cycle of sine function. I want to ignore them. And if you remember, this height was 1. This height was -1. And this one was 180. This is 0. This is 90. And this is 270, and this is 360 degrees. So that was the graph of the sine function, but just in one period. Forget about the rest. The rest will behave the same. So do you think what happens if I multiply this by 2? If I ask you to draw the graph of this function, this blue curve is the graph of sine x. Now I ask you to draw the graph of 2 sine x. Do you think this will change? Why? It was on 0, you multiply it by 2, it becomes 0. So this will not change. Okay? Do you think this point will change?
Yes.
It goes to 2. Yes? This one will be the same. Where this point would be? -2. It goes here. And this point will be the same. Okay, and then if you just draw the graph, what happens? It seems that you are stretching it. I cannot say, I don't know, do you feel this also stretching? But stretching in this case is very reasonable word. Yes, I am stretching the graph without affecting the width of the graph. Is that understandable? So, I multiply. But let me ask you one question. Here I told you k is positive, so it can also be equal to 1. Of course, if I multiply it by 1, that would be the same graph. But if I multiply it by 0.5, what will then happen? Yes?
It would be compressed.
Compressed, yes, in this case. But in this case, it becomes wider, yes? But so because we just work in trigonometry, so these words compressing or squeezing and stretching is better words. But here, so let me just draw that one. So assume that I want to draw this one now. Yes, what happens? This will not change. This will not change. If I multiply this height by 0, remains 0. But this height was already 1. I multiplied by 0.5, so this jumps to the middle point. And this will not change, agree? But this one will go here. And this will not change, agree? And then if I draw the graph, it would be the same graph, but squeezed with a factor of 2. Yes? Yes, it is squeezed with a factor of 2, or stretched with a factor of 0.5. Yes? Is that understandable? So, because of course I want you to understand it, this is not just for sine and cosine functions. In principle, you understand it for any particular function. Okay, for example, can you draw this graph 0.5 x squared? What happens? This will not change. Yes? This point was at height 1, now it goes at height 0.5. And then the other one would be the same. So you see, if I just draw them, I cannot say it is actually squeezed, or might be you can also say squeezed if you have access to the tips. Yes, you are squeezing it, but it is a little bit wider. Is that clear? But I want you to learn this. This is not hard thing, but in your lesson you're only concentrating on sine and cosine functions. Yes? Is that clear? Okay. So this is something I want you to remember. This is not in the formula sheet. Okay? So what is the effect of multiplying a function by a positive number? You need to remember two things for sine and cosine only, okay? If k is 1, of course nothing interesting happens, it becomes the same function. So the interesting cases will happen if k is between 0 and 1, and if k is greater than 1. Okay? For sine and cosine functions, I think it is a good word to use it. If k is greater than 1, what would be the effect? The effect would be stretching k times on the vertical axis, but I will not touch the horizontal axis. Okay, it doesn't have any effect on the horizontal axis. What does it mean? It means the zeros will remain still zeros, yes? They are not going in any direction. They will remain the same. Is that understandable? And now, if the number is somewhere between 0 and 1, what happens? It seems that you are squeezing it, but again in a vertical direction. But you do not touch the horizontal direction. Yeah, is that understandable? Okay. So this is not that tricky, but the effect would be here a little bit more tricky. What happens if I multiply my argument? Okay, so yeah, I think we can clean this part now. Okay, so let me just concentrate on this one. Okay, again, you want to understand it, so let me start with a concrete example. My function f of x is x squared. Okay, and let me for the time being take k to be 2 again. My goal is to find the graph of g of x, which is f of 2 times x. So be careful, I have changed, here I multiplied the function by 2, the output by 2, here I am multiplying my input by 2. That is the difference, yes? And I want to see what will happen in this case. Okay, how should I understand that? Let me just draw a picture again. First of all, let me calculate this. This becomes 2x to the power of 2. Agree? First of all, do you agree with me here? If f of x is this, f of 2x becomes this. Yes? But let me keep it in this form, even though I know the answer is 4x squared, but let me intentionally keep it in that way. Okay, so let us go now, draw the pictures here. So here x, I had 3 numbers involved, -1, 0, and 1. But let me just try to make sure that you understand. I want to increase this a little bit. So I want to have this -1. I want to have minus 0.5, I want to have 0, and I want to have 0.5, and finally 1. Yes? Okay, and then what happens here? This is y equals to x squared. The answer is 1. This to the power of 2 is 0.25. This to the power of 2 is 0. This to the power of 2 is 0.25, and this is 1. Yes? So let me just draw that picture once more. So here, let me make this 1 minus 1 a little bit bigger so that I can draw it better. So minus 1, and this is 1. And the middle would be 0.5, negative, positive. Yes? So this is 1 unit. And this is minus 1. I don't write these things. This is 0.5, this is minus 0.5. Okay, so if I give minus 1 here, the answer becomes 1. So if this is 1, let me keep the 1 here the same. Let me keep the scalings the same, okay? So scale is the same. That's the point. And then if I put minus 0.5, which is this point, I will get a quarter. So a quarter means that I divide this by half, again divided by half, yes? So this would be the point. And then if I put 0, I will get 0. And if I get 0.5, I get 0.25. And finally this point. I hope that you agree with me. This is what I can do a little bit better for the parabola here. Yes? But let us try to understand the graph of this function. You see, here, if I give 0.5 to x, then I have to put the same 0.5 here and draw the graph. But in this case, I give 0.5 to this function, to this x, but the value would be f of 1. Yes? So the value that I am calculating, for example, if I ask you what is g of 0.5, g of 0.5 is exactly the same number as f of 2 times 0.5, which is actually f of 1. Yes? So it reaches to the height of f. F reaches to some height when x is 1, but g reaches to the same height when x is 0.5. Yes? Is that understandable? Because g at 0.5 is the same number as f at 1. If I ask you what is f at 1, you will say the height is 1. But the new graph will reaches to this height, but not at that point. At which point? At 0.5. Yes? So for the graph of this function, this is 0.5. I will reach, for this new function, I will reach to the same height, but not here, a little bit earlier. So that would be this point. Yes? And the same is the case. I will reach to height 1 here, but I will reach to height 1 when I am here. Yes? So if I want to draw the picture, again, I will get something like this. Yes? So, but you see, it's not that clear what is happening. Here, I am multiplying it by 0.5. Yes? I get this graph. But in the case of sine and cosine function, it is easier to understand. Okay? So, but let me just clean this one now. I ask you what will happen if I do the same thing for sine. So, let me just draw the graph of sine function in one period again, from 0 to 360 degrees. Yes? So here I have 0, here I have 180, here I have 360, and in the middle this is 90, here it's 270 degrees. Yes? And this height is 1, and this one is minus 1. Okay, so what do you think will happen? This is the graph of this function. Now I'm asking you to draw the graph of this function. I am multiplying 2 to the x instead of multiplying the whole function. Okay, what do you think will happen? This is important to understand. So, the old function reaches to this height when the x is 90. Do you think this function also reaches to height 1 at some point? Yes, but where? Earlier or later? Earlier, yes, when it is 45, agree? So the new function, when I am at 45 degrees, reaches to the same height as the previous function, yes? Because if you put 45 here, you have to multiply it by 2, it becomes 90, it becomes sine of 90, which is 1. So if I want to reach to the height 1, I reach to that height earlier. So this bit goes to 1. Yes or no?
Yes.
Okay. And of course, what happens if I give 0? Sine 2 times 0 is 0, sine of 0 is again 0. So that would be the same thing. Okay, can I reach to this one? What is the height for this point? It is 0. The normal function reached to 0 once here, but this function reaches to that 0 earlier.
Yes.
At where? At 90. Is that understandable? So I reach to this at 90. Yes? And then here, this point, I reach to -1, the old function. I reach to -1 when the angle is 270 degrees. Do you think for this function I can reach to height -1? Yes, but earlier. Where? 135. Yes, where is 135? Somewhere here. Yes? So I will, because this is 90, this is 180, so that is 135. So I will reach to this point. Yes? What happens for 360 degrees? The height is 0. I divide it by 2, I go there. Yes? So if I want to draw the picture, it would be this one. Yes? Is that understandable? So you see what is happening now? I am multiplying x by 2, but the effect is squeezing. Is that understandable? I am squeezing in which direction? Horizontal direction. Is that understandable? So this is a little bit unusual. The horizontal direction is the other way around usually. It's counterintuitive. Here we multiplied by 2, we stretched. We multiplied by 0.5, we squeezed in the vertical direction. Yes, this was more or less intuitive, yes, because you multiply by 2, you feel that you are making it bigger. You multiply by 0.5, you think that you are pressing it. But here, this is the other way around. I am multiplying x by 2, this is counterintuitive. I am not stretching it, I am still squeezing it. But in which direction? Horizontal direction. Is that understandable? And I hope that you agree with me. Of course, so what is happening, by the way? What was the period of this? Of course, you know the blue curve will continue forever like this. So if I ask you what is the period of the blue curve, what is your answer? What is the period of the blue curve? Assuming that it will continue forever exactly like this. So what is the period? 360. But what is the period of the red one? 180. So it is extremely important. The effect, if I multiply x in trigonometric functions, this function is not periodic at all. But if I have the periodic function for sine and cosine, if I start manipulating this by multiplying it by a number, I will affect the period. Okay? But if I start multiplying the function by a number, if I ask you what is the period of the blue one, everyone, what is the period of the blue one? 360. What is the period of the red one? And what is the green one? All they are the same. I am not affecting the period at all by multiplying the function by a number. Yes? But I am affecting something. I am affecting the height. This height in physics, in mathematics we use the same word. It's called amplitude. Okay? If you consider this is the wave, I don't know, have you studied waves in physics?
Yes.
Yes, the word amplitude is probably familiar to you. This amplitude is the disturbance of a wave from its equilibrium position. Yes? So if I have a rope, it's in equilibrium position. Yes? and then if I disturb it, it goes up and down. This height, the distance from the highest point to the equilibrium position is called the amplitude of the wave. And that's exactly the same. So if I ask you what is the amplitude of the blue curve, what the answer is? What's the answer of the amplitude of the blue curve? 1. Don't say 2. The height of the highest point of the wave to the equilibrium position is called the amplitude. What is the amplitude of the red curve here? And what's the amplitude of the green one? 0.5. And be careful. Amplitude by definition is a positive number. Yes? Amplitude is positive by definition. So, we learned something very interesting. If I multiply sine and cosine, I am affecting the amplitude. Yes? If I multiply the x of sine and cosine, I am not affecting the amplitude, I'm affecting the period. Yes? And you need to memorize that somehow, understand and memorize, because it's not in the formula sheet. So let us repeat. If I multiply my function by a number larger than 1, am I increasing the amplitude or decreasing it? I'm increasing it. If I multiply by a number between 0 and 1, I am decreasing it. It's completely natural, yes, because you understand what's going on. And now, if I multiply x, the argument, this is called the argument of sine. If I multiply argument by a number larger than 1, am I increasing or decreasing the period? Decreasing. And if I multiply it by a number between 0 and 1, I will increase this by the same factor. Is that understandable? Yes or no? Yes? Okay. So, probably that's a good thing you explore these things by GeoGebra. Okay? But I have to tell you how to adjust GeoGebra to work with degrees. I will tell you that. I told you it's the conventional unit of measuring angle is radians, not degrees. Okay? Okay. I hope that this is more or less understandable for you. So let me write something here for you. So these two functions for the time being are famous. I have y equals to sine x. I have y equals to cosine x. You already know the graph of these functions. My examples are based on sine function, but you can do the same thing for cosine function. But we learn something like this. We want to know what happens if I have a times sine kx. And what can I write about the same for cosine kx? Okay, now you see that I am both multiplying my function and the argument. Of course, this is easy to understand, yes? For example, what do you think would be the graph, I don't know, of 2 sine 5x? First of all, tell me, what is the amplitude of this function? This function.
It should be 2.
It is 2, because that's the maximum height, yes? So if I ask you what is the maximum of this function, how do you answer that? You see that this is a function, sine function. Do you remember? Sine was the y-coordinate on the unit circle, and cosine was the x-coordinate in the unit circle. But in the you yourself say that this is the unit circle. So it means that the maximum height is 1, the minimum height is -1. The maximum going to the right is 1. The minimum is -1. So the maximum of sine is 1. The minimum of sine is -1. The maximum of cosine is 1. Both of them. Maximum of cosine is 1. Minimum of cosine is -1. So if I ask you what is the amplitude, I mean that what is the highest point. And that is 2. Yes? And then what is the period? So what was the period here? I want you to find the pattern. That would be enough. So what was the period of this one? It was 180. Do you remember how? Because we squeezed it by a factor of 2. Yes. The original period was 360 degrees. Yes. And then we multiplied this by 2. The period was 180. What do you think if it will happen if I multiply it by 3 instead of 2? What would be the period? 120, yes? Is that clear? So the period is also very good to know. So t, the period, this symbol t is for the period. I think this formula is in the formula sheet. So it is, can you tell me for the formula for the period of these two functions, according to the intuition that you got here? Because if you can get it, you don't need to memorize it, you know it. So what is the period? Here the period was 180. I asked you what happens for the period of this one. Some of you answered actually 120. So now probably you understand what the pattern is, yes?
360 divided by k.
K, yes. Yes. And I want to emphasize to put an absolute value here. It is probably overemphasizing, but if in case k is negative, you have to put the positive one. And the amplitude, what is the amplitude? The amplitude is absolute value of A. If this A is positive, you just say it. If it's A is negative, for example, and by the way, let me talk about, I don't know why the book hasn't talked about negative values, might be they are in exercises. What do you think will happen with negative values of K? Okay, that's also good to know. But I think this is a little bit more tricky. Might be this is the reason that the book don't want to discuss about this. Let me ask you one question. Very simple. I give you the graph of sine function. I ask you to draw the graph of negative sine x. I'm multiplying it by -1. I haven't discussed that one so far. So what is the graph of that function? What would be the effect of multiplying the whole function by a negative sign? Yes, Jonathan?
It's the same thing, but you go in the other direction.
What do you mean by in the other direction?
So instead of starting by going towards x1, you start by going towards x minus 1.
Yeah, what is the meaning of that graph? It is the mirror image of the graph with respect to the x-axis. Yes? If I is that understandable? Because when I multiply my function by -1, the positive height will go to the negative height with the same length. The negative height will go to the positive height with the same length. Yes? So this part of the graph, which is above the x-axis, will go here. And this part of the graph will go up. So this is minus sine x. Is that understandable? So what do you think would be minus 2x? Minus 2 sine x. So first I multiply by a minus sign, I get this orange one, and then, so I write it as 2 times minus sine x. I already know minus sine x, so now I stretch it 2 times larger. Yes? So then it goes here. So this graph would be the graph of minus 2 sine x. So is that understandable? But the effect of multiplying x is a little bit more counterintuitive probably. What do you think will happen if I multiply a function, the x of the function, by a negative sign? So if you multiply your function by a negative sign, what you need to do is just reflect it about the x-axis. The parts up goes down, the parts down goes up. So what happens for multiplying the x by a negative sign in general? Yes?
So it should be the same because when you explained to us earlier that sine of minus a number is the same as pulling the minus sign out.
Yes.
So it should.
And that was a clever answer. For the case of sine, that was completely right. So it becomes exactly the same thing. Because sine of minus x is minus sine of x, and that's it. But I'm talking in general now. If I give you any function, for example, if I give you the graph of this function, okay, and I ask you to change x to minus x everywhere to produce you a new function. And let me simplify that. This function. Yes? So what I'm saying is that I give you the graph of this function. I want you to understand the operations, this effect. I give you this function, you just draw it with GeoGebra, but you want to guess, before drawing it using GeoGebra, what will happen if every x is replaced by minus x. What do you think will happen? Sorry. What do you think will happen? Yes?
It's the mirror image unless it is to the power of an even number.
No, what would be the effect, geometric effect of this algebraic operation? I am doing some algebra here. I am changing x to minus x. This is algebra. And then it has some geometric effect. How should I see that? For example, in the previous case, you told me it's a reflection of the graph with respect to the x-axis. Can you describe it in this way for this new operation? X goes to minus x, yes?
And it's a reflection with respect to the y-axis.
It seems natural, yes? It should be a reflection with respect to the y-axis. Why is that? Because when I give x equal to the 1 and I go to some particular height in the original function, now I have to give minus 1 to reach to the same height. Is that understandable? So it is the reflection with respect to the y-axis. So if you multiply x by a negative sign, it is important, by the way, to understand these things. So if you know the graph of this function, what will happen if I replace every single x with minus x? I get a new function. If I draw the graph of the new function, I immediately see that it is the reflection of the original graph with respect to the y-axis, yes? But the reason is that, so you see what is happening here, coincidentally the effect were the same, yes, as you told me. So you see here, this orange graph is minus sine x. Now I am asking you to draw sine minus x. What I have to do, I have to take this blue curve and draw it from here. Do you agree? Yes or no? But this is the continuation of this orange graph. So in this case it was just a coincidence. It doesn't matter if you flip with respect to the x or you flip with respect to the y-axis. It was just a coincidence. Is that understandable? Okay, let me ask you one thing. What would be the graph of cosine minus x? Yes?
Cosine of minus x is just cosine.
Cosine x. So it is not anything. There is no difference. Yes? Yes. So let me see what I wanted to talk about. Okay, so this is important. I give you a function so I can do these operations simultaneously. Multiply my argument by a number, multiply my function by a number. Yes? So this means that I have two operations doing it consecutively, and it doesn't matter if you take your graph, consider this effect first and this coming after that, or the other way around. Consider this one first and this one. But which one I think is better for us, I think, to do easily? I myself prefer to apply multiplication by a first to find the bigger graph or a smaller graph and then squeeze it or stretch it. Yes? It doesn't matter. You can also first stretch or squeeze and then stretch or squeeze in the other direction. Yes? Is that understandable? This is commutative. This commutativity is just a commutative operation in geometry. It doesn't matter in which order you do it. Okay, now I think if you understood what I said, in principle you should be able to discover these things yourself. Because I want you to be engaged with, I want to tell you, for example, what do you think will happen before I teach it? I teach that. If I give you the graph of this function, this time I add 1, for example, to this function, or I add 1 to the x of the function. So do you understand the differences? Here, I started with a function. I can have two scenarios. I add a number to the whole output, or I can replace every x with x plus 1. I want to ask you if you have good understanding of what I said. They are not exactly the same thing, but the logic behind them would be the same. What will happen for this graph? What will happen for this graph if I do this operation and this operation? Yes? Which one do you want to answer first?
First, x to the power of 2 plus 1.
Yes. What happens?
It will be stretched on the vertical axis.
No.
Vertical.
Second chance.
Isn't it that?
No. Yes, Abigail?
You cross the y-axis, but in 1, point 1.
So, okay, what can you say? What is the meaning of what you are saying?
It will erase,
Yes?
move up.
Yeah, it will move up.
Yeah.
It's a shift 1 unit upward. It's like a rigid object. I take it and increase 1 unit. Why is that? It's understandable because I am adding 1 to the output. Yes? For example, the middle point, which was the origin, will be shifted 1 unit up. But every other point will be shifted 1 unit up. Yes? Is that understandable? So the effect of adding a number to graph is the simplest possible scenario. You take it and shift it upward. Yes? What happens if I add negative 1 to it? Yeah, it will be shifted downwards. Yes? 1 unit. But the effect of this one is, again, needs a little bit of thinking. So first of all, let me ask you, everyone understand what I said or no? Yes or no? If you don't understand and don't ask the question, that is up to you, okay? So if you don't understand, please ask questions. Okay, what about this one? What do you think will happen if I add 1 to the x, not to the whole function?
Sort of x.
Yes?
Shift 1 in the x direction instead.
Okay, that's right, but it's not complete. Which direction?
No.
Left or right?
Well, to the right this time.
Okay, how many of you agrees?
Yes, that's also.
No, the opposite one.
It goes to the left. It's counterintuitive again. Yes? If you add 1 unit to the x, the graph will not move 1 unit to the right. It goes 1 unit to the left. Why is that? Again, let me just repeat this part because that's important to understand. So, for example, this graph will reaches to the height 1 when x is 1. Do you agree? So this is 1 point. This is also another point of that graph. So let me just draw something here. So this is y is equal to x squared. So this old graph reaches to height 1 when x is equal to 1. It means that whenever the input is 1, I will reach to height 1. Yes? Yes or no? But for this case, I reach to input 1 earlier. Yes? In order to reach to the input 1, for having this input equal to 1, I have to put x equal to 1. But for having this input equal to 1, I have to put x equal to 0. So I reach to that height earlier. Is that understandable? Yes or no? So it means that if I put x equal to 0 here, 0 plus 1 becomes 1 to the power of 2, which becomes 1. So at 0 I go to 1. When do I go to 0 in this scenario? I go to 0 here when x is equal to 0, but I reach to the height 0 earlier when I am here. Yes? So then you see that the graph would be this one. So it is 1 unit shift, but 1 unit to the left. So the x-axis in both cases is counterintuitive. Just remember this word, yes? You multiply x by 2, it will be squeezed 2 times. You multiply it by 0.5, it will be stretched 2 times, yes? And then here, if you add something to your x, the effect of adding something to x is a shift on the x direction. But if you add positive, it does not go to the right, it goes to the left. And if you add negative, it goes to the right. Is that understandable? Yes or no?
Yes.
Yes? Okay. So now we can also do the same thing with sine and cosine function. So, for example, let us consider the function y equals to sine x. Okay, the same thing. So let me just draw this again. (180, 90), yes, and then I have this one, and then here I have 360, and this is minus 1. 270, yes? So this is y equals to sine x, of course, in just one single period. Okay, so now, if I ask you, can you imagine the graph of sine x plus 1, what will happen, do you think? It will actually shift in which direction? In the vertical direction, upwards or downwards? Upwards, yes? So 1 unit. So this, what does it mean? It means that my height here is 0. I shift it 1 unit up. This point goes to here. Yes? And this point was already in height 1. I shift it, it goes 1 more, so it reaches to this point 2. Yes? And this will go here. I don't know. This will go where? On the x-axis. This will go to the 1. And this would be the curve. Okay? One question, am I affecting the period of this? Of course, you need to consider this black one continues forever. The same happens for the red one. Yes? Am I affecting the period? Am I affecting the period of this function by shifting up and down? No. The period is still the same. It's important for this lesson. Okay? So, adding a number does not have any effect in that case. Okay, let me just also draw this one for you. What do you think will happen for sine of x plus 1? But x plus 1 is a bad one, because 1 is a very small number. So let me make x plus 90. Yes? Let us see what happens. What would be the effect of adding 90 degrees to x? It is a shift on the horizontal direction, but right or left? Do you mind? Let me, this time draw the negative one, because we talked about positive here. So let me just draw this one. Yes? So here, for example, if I give 0 to this, what will happen? It becomes sine of minus 90, which is minus 1. Yes? So sine of minus, so this will be here. Now this, of course, this is a little bit strange. If I want to draw one part, you might think that I am still shifting on the y direction. This is not the case. It's an illusion probably. But let me see what happens. So this means that if I want to draw this, let me just do it. I have to shift this 90 degrees to the right. So this point will be here. Okay? This point will go 90 degrees, it will be here. This point will be here. Yes? And this point will be here. And this point, of course, will be here. And then I draw that. Yes? Yeah, it is clear actually. So if you draw this one, it is 90 degrees shift to the right. This is when sine x is minus 90. You can confirm that. For example, if I put 90 degrees here, what is the answer to y? If I put 90 minus 90 is 0, sine of 0 is 0. So you see, when x is 90, the green should show 0 height, and that is correct. When x is 180, minus 90 is 90, sine of 90 is 1. So that is right. At the 180, the green one showing height 1. So you see, it is shifting to the right 90 degrees, yes? But again, do you think I am affecting the period? Am I affecting the amplitude? So I hope that you agree all these curves have the same period. All of them have the same amplitude as well. Yes? What is the difference? The difference is that the equilibrium point is being shifted for the first case. Yes? The equilibrium line, equilibrium line for this sine function is the x-axis. This wave is going around the x-axis. But this red one is not oscillating around the x-axis. It is oscillating around this axis. Yes? So the equilibrium axis is being shifted up or down. Yes? But the period is not affected. The amplitude is not affected. Is that understandable? So if I ask you what is the amplitude of this function, what is your answer? What is the amplitude of this function? 1. What is the period of this function? 360 degrees. Yes? Is that clear? Okay. Now, might be you are able to guess what comes next. We can have four of these operations in one function. Yes? What we do, I give you this function, and in principle, you should know a lot about this function. I multiply my function. Okay? I multiply x by b. I add c to it. So all these operations can be done in over one function. Yes? And then you already know how to understand these functions. So what do you think? This will affect what? This multiplication affect the amplitude. This b will affect what? The period. Yes? So these two, it's important. When you multiply this function by a, you are changing the amplitude. When you are multiplying x by b, you are changing the period. And if you are adding something to it, you are shifting a little bit to the right or to the left, depending to the sign of the number that you are adding. Yes? But let me ask you something which is actually a matter of confusion most of the time. Okay? Let me ask you something. Let me just concentrate on these two numbers. What do you think will happen here? Okay, so tell me what to do. I give you the sine function, assume that this is a rigid rod in your hand, and I ask you, not rigid rod, probably elastic rubber band or something. How do you go from here to here? Can you describe it for me? I have seen many students make mistake in guessing this. I want you to understand what is going on.
This is changing time.
Yes, Nabil?
First you squeeze it and
Squeeze it by a factor of 2 on the horizontal direction. Yes.
And then you have to shift the position of it. So
90 degrees to the right or to the left?
Left.
No, it is positive.
So right.
Yes. You are right. Yes, positive to the left. Yes. How many of you agree with this one? Yes. How many of you agree with this? So she says that if you give me the graph of this one, because of this factor of 2, I squeeze it. Okay, because the factor is bigger in the x direction, I squeeze it, and when I get the squeezed version, I move it to the right, to the left 90 degrees. How many of you agree with that one? Okay, but this is not correct. Be careful about that, because operations, do you see that sometimes I talk about commutativity when I was talking about it in set theory probably. These are two geometrical operations, yes? These are two operations. Shift up and down, squeeze, these are geometrical operations that I am doing on a shape, yes? There is no guarantee that they are commutative. You need to be careful. So what you said, let me tell you something. What you said is the graph of this function. It's a very, very delicate problem. I want you to understand that. So if I give you this function, y is equal to sine x, what you said in the beginning is right. Yes? But if I want, now this is the squeezing process. Now I want to go to the shifting process. The shifting process, I told you this is the case. Yes? You need to replace x with x plus c, then the effect would be a shift of amount c. Is that understandable? Yes or no? So if I take every x in my function and replace that x with x plus c, the effect would be a shift of amount c in appropriate direction. Yes? But this is not happening here. If after you squeezed, yes, after you squeezed, you get a new function. In this new function, if you change x to x plus 90, you are right. Then I will be shifted to the left 90 degrees. But then if I replace x with x plus 90, it will generate not that function. It will generate this function. Yes? I am just replacing x with x plus 90. Everywhere. I have to write it in this way. Yes? And then if you multiply 2, it becomes 2x plus 180. So what you described is the graph of this function, not the graph of what I demanded. Is that understandable? Yes. So when you squeeze first, you are changing your function, and the new operation is being done on the new function, not on the previous one. There are no previous one. Yes? It's important. Okay, so here, let me just describe. This is very, very important to understand. So, let us do something like this. Now, can you tell me if I want to draw this graph, can you correct it yourself, Nabila?
On first you squeeze it.
Yes, but shift it how much?
90 degrees.
Anyone else? 45, yes? You have to shift 45. Yes? Why? Because you squeeze it, and then if you understand that if you shift it like this, after being put here, it will be 90, and that would be the graph that I demanded for. So you need to guess what would be the correct number so that after being multiplied by 2 becomes the number given there. Yes? Is that understandable? Yes or no? Okay. You might think that what is the problem? Let us first shift. Is that possible? Let us first shift instead of squeezing. Let us see if it is easier or not. So you might say that what? I shift first by 90 and then squeeze. Squeeze, what should I do? I have to multiply it by 2. Yes? So that is correct. So you first shift and then squeeze. You are changing x by 2x. So you are squeezing that. And then these two operations are not commutative. So it is very interesting. So if you first shift and then squeeze, it's not the same thing if you first squeeze and then shift. Yes? No, that I have to correct. This is also commutative, but the amount of shift is different. Yes? So here, how much I am shifting? I am shifting 90 degrees and then squeezing. If I want to reach to this function in the other way around, I can squeeze first, but I have to shift 45, not 90. Is that understandable? Yes or no? Okay, so that is a delicate thing that I wanted to know. So now let us go back here. If I ask you what is this function finally, Okay, tell me the amplitude. Let me write amplitude. Oh, by the way, I forgot. I can also add something to it. Yes? So you see, I multiply my function. I multiply my x of my function. I add a number to my function. I add a number to my x. I have done all the operations. Sorry, I forgot to write d as well. Okay? So now tell me, for this function, it's important to understand these things. So what is the amplitude? Assuming that a is positive. So let us assume that a is positive and b is positive as well. Okay, so what is the amplitude? What is that? I can also have the same thing. There is no difference. I can have cosine. Let me write everything in capital letters. Okay, so amplitude, when I say amplitude, I mean this one and that one. Can you tell me what is the amplitude? Amplitude was the disturbance from the equilibrium position. Yes? If I do not have this d, where is the equilibrium line? X-axis. Yes? Now I have d, I have a shift up or down. So the equilibrium line is no longer the x-axis, is y equals to d-axis, or either up or down. Yes? Is that understandable? Yes or no? Because I am adding a number, I told you the effect of adding a number is going up and down. So you move the function up or down based on the sign of this d. And this would be the new equilibrium line. Yes? But still, how much this will be disturbed? A. Yes? So this amplitude is again A. Let me emphasize absolute value. Okay, I have written A and B are positive. So amplitude is A. Period. What is the period? What is the period? There is a symbol for the period. So T is the period is equal to the 360 degrees divided by B. So I think this formula is in the formula sheet. So, but I think it's important to remember this by heart to understand what's going on. Is that understandable? Now I want to add two more formulas. They are not in the formula sheet, but they are very important. Let me ask you first, and then I will continue with what I said here. So, can you tell me, for example, let us concentrate here only. Can you tell me what would be y maximum? What is the highest height of this function? I am asking you, what is the y maximum? What is the height? What is the maximum y that you can achieve? Yes?
A plus d.
A plus d. Yes? Because d is just a constant, you cannot manipulate it. But you have this x under control. You can just try to change x. By changing x, you are changing this part. It goes up and down, yes? But you know the maximum value that sine function can achieve is 1 unit. So if you want to make y maximum, it is completely natural to make this part maximum. And this part maximum is 1. So the maximum, as you told, is exactly correct. So what was your name, sorry?
Mariana.
Maria, okay. What is the minimum value for y? What is the minimum value for y? Minus a plus d, yes? Because the minimum value of sine is minus. The reason that I am teaching you, these two formulas are not in the book, but there are many exercises that the graph is given. By looking at the graph, you are supposed to tell me what is A, what is B, what is C, what is D. Okay, so this is the reason I want you to understand. Even if you forget, if you understand how what to do, you can find it. Now you see what happens if I add them. What happens if I add them? This one and that one are gone, 2D. And then D becomes, this is a nice formula. So if you see a oscillating graph of sine or cosine function of this type, if I ask you to find D, what is D, what you need to do, you need to find the highest value for y in the graph. You need to find the lowest value for the y in the graph, add them and divide them by 2, it gives you D. Yes? And now let us do, what can I do for A? I subtract them and divide by 2. Why? Because y max minus y min is equal to A plus D minus A plus D. And then if I remove the pair of brackets, this becomes positive A, this becomes negative D, this one and that one are gone, it becomes 2A. Yes? And then you divide by 2, you get a formula for A. Y max, Y min, divided by 2. So I don't think these formulas are mentioned in the book or in the formula sheet, but if you understand, you can find them yourself. So, if I give you a graph, and I ask you, this graph is the graph of such a function, this is definitely a question in the exam, okay? Find A, B, C, and D. Yes? So for finding D, don't worry. You find the maximum height, minimum height, add them, divide by 2, it becomes D. Yes? But for A, the answer is again, you find the highest point, the lowest point, subtract them and divide by 2. Yes? But now, can you tell me, by looking at the graph, so I realize how to find A, I realize how to find D. Now, how can I find B? By looking at the graph. Yeah. B is connected to period. So you read the period, put it here and find B. Yes? Is that understandable? Just by looking at the graph, in principle you should learn how to read the period. When you read it, you put it in this formula, then you have T, you have this number, this is the only unknown, you find it. Yes? Yes or no? Are we done now? Or not yet? But the lesson is continuing still, yes. Okay, so this would be B. Okay. And then of course for the C it would be a little bit problematic. By the way, A, B and D are unique. But I hope that you immediately can convince me that there is no unique answer for C. There are infinitely many answers, yes? Why is that? Can you feel it from geometrical point of view? Because these functions are periodic, so they are repeating themselves. Yes? Yes? So, if I move it somehow to the right or left so that the function again overlaps with the old function, I can actually do it with longer movements. Is that understandable? Yes or no? Because you see that I have a function, let me tell you here. If I have a function, sine x, you see, and then I ask you what is sine of x plus 360 degrees. On the one hand, it should be a shift, yes? On the other hand, I return back to the same function, yes? Why there should be a shift? Because I am adding a number to x, it is 360 degrees shift to the left. Yes? It's positive, it is to the left. Okay? But, do you think they are different? No, yes? Because you know that these two functions are the same. And I can also write sine of x plus 720 degrees. Yes? I am shifting it 720 degrees this time. But I will end up with the same graph. Because this function is periodic. So this is why A, B and D are uniquely determined by looking at the graph. But for C, you can have different answers. This is why usually people ask, what is the minimum positive value for C? Or if I just say, give me a C, whatever you give me, which is correct, that's okay. But if I ask, what is the minimum positive value for C, or positive minimum, I don't know, a number between this interval that works for C, you need to then be careful about that. But the point is that I want you to answer this question. Is this shift C units or not? by looking at this. Is this shift C units or not? Again, what Nabila actually told here, that's also the same thing. I'm just repeating it. By looking at this graph, do you think the shift on the x direction is C units or not? Do you remember for this one? So for sine 2x plus 90, do you remember what was the shift?
Yeah.
It was 45, not 90. Yes, that's the same question again. By looking at this graph, is the shift C units or not? No. But what is that? C divided by B. So in principle, how did you understand the shift is 45? You wrote it in this way in your head, yes? So this is the shift. Okay? So here, if I factor B out, this becomes x plus C over B. So this is the amount of shift. Yes? But this is not unique. Because this function is periodic, I can increase this shift. Again, it's possible to go back to the same graph. Yes? Is that understandable? How much time we are left? 5 minutes.
Yeah, something like that.
Okay, something like that. So I wanted to have some demonstrations on GeoGebra. So I think, let me just tell you something about the adjustments for the time being, so that if you are interested in working, so that you know how to do it at home. But next time I will also continue this lesson, and then this will be done. There will be 2 topics, radians, and which is not that hard, but another topic which we are very important is trigonometric equations, which is the probably most important part of this chapter. Okay, and then we are done. If we can finalize everything, so I think week 43 we will be finalized. So we will have a full chapter test for that. Okay. So let me just. Is it 11:25? Yes or no? Yes. So let me just. Yeah, it's a little bit unfortunate that we have to teach in degrees everything so far. So let me just give you some adjustments if you want to. I just try to figure it myself. In principle, we should be able to do that. So move the graphics. So yeah, let me put it in the center. So you see that the standard one is, the scalings are 1 and 1. They are the same, yes? But here, for example, if I want to draw the sine function y equals to sine x, for example, so this is the sine function. This is not a good one, yes, because you don't feel the zeros. The zero is, by the way, could you guess the zero would be around this number? Not probably, yes.
Yes, probably.
Yes,
because of Morten has explained.
Okay, that's it. So that's the radian. So 180 degrees is equivalent to pi radian. And pi is the famous 3.14 number, yes? And you see that the 0 is coming a little bit after 3. So that is exactly the pi number, okay? But if I want to adjust that, I would recommend you to go to, I don't know, right click here and go to graphics. And then go to the x-axis. No, let me just go here. So let me change this scaling. Make it 360 is good. Let me see. No, the other way around, sorry. I have to change this one. No, this is 1. This I have to change to 360. But then another problem arises apparently. It's not working right. Why? Yes. So a very strange thing happens, yes? The reason is that the graph actually goes so high that you cannot see it. The reason is that this is just 0.5 now, yes? Okay, and then that would be the graph of sine function. You can feel it, that's not a sine function at all, yes? Yeah, it's going so up, I have to zoom in, and then finally it return back, yes, when I reach to 1. So to be able to solve this problem, so that at least, I told you that the degree is not the standard units that we are supposed to work. So what I think we can do, we can go here, and what we can do is just to go to the x-axis, make this unit to degrees. Okay, now this is better a little bit, but not that much. and then I start. So let me. I think it will start fixing it itself. So let me just move it around. But I don't know why it's not working here now. So it might be. So now this is. I want to make this one. So what do you think I should do? I need to rescale it in a way that I can see 360 degrees in front of my eyes. Yes. What?
Average 1 and 360.
So this is unit in degrees, and you're saying that make it what? I go here, basics. Pardon?
Change that to 1.
Yes, and then this one to 300. So that was that is 1 now.
Change that to
360. Yes, the one that I did first was correct. Why it doesn't work? Let us see. It insists that I will not do that. Yes, it worked. Yes. And then, unfortunately, now we are actually here. But I need to zoom in.
Okay.
Yeah, that's also not working. No, I fixed it before having the lesson. I am a little bit tired now. No, this scaling doesn't work. So what I want to do, I want to keep 360 degrees. No, I understand. That was what I'm saying. That was correct. The reason is that GeoGebra is using radians still. I have changed the scaling and the axis, but this x by default is in radians. Okay, sorry for that. So you need, what I completely forgot because I'm tired. So you have to multiply this for the time being by pi and divide it by 180. Then everything would be in degrees. By default, GeoGebra is using radian to draw the graphs. Yes, so let me just, I messed up, sorry. So, but I need to go to the keyboard here, and I press pi here, and then go here, and then divide by 180, and then this is the correct one. The reason that this doesn't work, I have to go probably and fix that one to the other scenario. Let us see finally it works or not. No. No, but it should work. Okay, because now I have to zoom in. No, zoom out. I have to make this one equal to 1 so that you can see. It is clear that this height is not comparable to 20. I have to make this height to be equal to 1 so that you can see it. Yeah, it will work, no worries. Yeah. Now it is 1. So, okay, let us go back again. Just one moment. Okay, it has been chosen. So let me just yes. Oh, okay. It is back to this one. So I don't. Yes.
The x-axis, shouldn't it be like 90? You want
no, I want to see the whole 360. Yeah, let me make it 90. But no, let me go here so that I can have it degrees. Yes, that's correct. But the scaling is wrong. I don't understand how it works here. So if I go...
So the left one, choose it to be 90.
This one?
Yeah.
This one, I choose it to be 90. Yes.
And then the right one...
Yes, let me see how it works. No. No, there is something wrong because I did it very simply before the lecture. Yes? Yes?
There was one when you go to x-axis, it says distance. If you change that to 90, maybe it just should be 90 and then the next one will be 180.
Okay, but as I remember, I didn't touch that one. But the problem is that I do not have any graphs now. Okay, I will try to fix this one, but this is, I'm completely sure about that. For the time being, if you want to work with degrees, put this pi over 180. Okay, I will try to fix it. I'm very tired. I did it before having the lecture, don't mess it up, but again I messed it up. Okay, see you later, thank you. Okay, sorry, so let me just do it again. Sorry, I was confused myself. So let me go here. What I wanted to say is that you go here to the graphics, and then, for example, you can change this one to 90. That's good. And then, yes. So I don't know why this is not affecting. So let me make it 90 again one more time. So, okay. So that is 90. So I go to x-axis and I will change the units to degrees. Okay. And then what you see is that this is 1 degree. I want to have numbers around 360 degrees or so in my view. So I will zoom actually out. And then, okay, so this would be around, yeah, that's good. So I think up to 720 is good. And then this height is 1. So that's, everything is good. But you see, if I just put, again, if I just put 1 equals to sine of x, and I ask GeoGebra to draw this, GeoGebra will draw this one, which is also a sine function, but it's so squeezed that you cannot see the oscillations. But the problem is that GeoGebra by default take x to be in radian mode. So if you want to switch to degree mode, even though I haven't taught you that yet, but just take this for granted for me, and then we will later understand why this is the case. You need to multiply your argument by pi and then divide it by 180. Yes, for the time being. And this will give you a reasonable graph of sine of x in which the x-axis is based on degrees. And I think this is reasonable. So you see, if I ask you by looking at the graph of this function, can you read the period? So you realize that from here to here is 1 period, because if I start copy and pasting this portion of the graph, I will generate the whole graph. And then each one of these grids, how much is that? 1, 2, 3, 4, 5. 5 of them is 100 degrees. So each one of these grids is 20 degrees. And if I ask you what is this period, so this is 1, 2, 3. So this is 60 degrees, and from here to here is 300 degrees. So in total it is 360 degrees. For example, if you want to see what happens if I multiply it by 2, it should be squeezed, and you see that it is now squeezed. Yes. If I multiply it by 0.5, it should be stretched, and that you see that this is now stretched. Okay. And for example, if I add a number to it, it will actually go up and down. If I add -3, for example, it will go lower. Yes, this is the graph, so it is actually shifting up and down. And if I multiply this function, for example, by 3, then the amplitude will change actually. Yes, so you see now the amplitude is bigger. So how should I calculate the amplitude? I find the maximum value, the minimum value, I subtract them and divide by 2. So the maximum value of y is 0. The minimum value is -6. 0 minus -6 divided by 2 is 3. So the amplitude of this function is actually 3. Yes? Okay, sorry. So now hopefully you understand. But later that we work in radians, we don't need to mess it up. What we type is exactly what we mean. And we do not need to set up anything in GeoGebra. Okay? Thank you very much and have a nice weekend. Thank you.